Hello, everyone. Thank you for coming today. The main purpose of this document is to introduce the commonly used profiles in BR EDR Bluetooth and their usage in the Realtek SDK. This document will sequentially introduce the following profiles: A2DP, AVRCP, HFP, PBAP, SPP, IAP, HID MAP OPP, PAN. This report mainly focuses on introductory content. For the technical details, you can refer to the SDK online documentation for more information. The Advanced Audio Distribution Profile, A2DP, defines the protocols and procedures that realize distribution of audio content of high quality in mono or stereo on ACL channels. A typical usage case is the streaming of music content from a stereo music player to headphones or speakers. The audio data is compressed in a proper format for efficient use of the limited bandwidth. A typical usage case is the streaming of music content from a stereo music player to headphones or speakers. The audio data is compressed in a proper format for efficient use of the limited bandwidth. The following roles are defined for devices that implement A2DP. A device is the SRC when it acts as a source of a digital audio stream that is delivered to the SNK of the Piconet. A device is the SNK when it acts as a sink of a digital audio stream delivered from the SRC on the same Piconet. As shown in the diagram, when a music player is connected to headphones, the player transmits music to the headphones, with the player acting as the SRC role and the headphones as the SNK role. When the music player is connected to a microphone, the microphone sends the collected sound to the player, with the player acting as the SNK and the microphone as the SRC. This figure shows the relationship between applications and A2DP and Bluetooth host. Above the horizon line is developed by the applications. Below the horizon line is developed by Realtek. The application performs A2DP operations by calling the API and receives the corresponding events and statuses through a callback. The functions provided by A2DP APIs in SDK are as below. Connecting and disconnecting, including functions to connect and disconnect A2DP. Streaming, including functions to send stream data, etc. More details of A2DP related APIs are provided in the SDK. Taking the BT-A2DP Stream Start Confirm interface in the Realtek SDK as an example, the interaction flow is shown in the diagram. The remote device initiates A2DP Start, the application receives Stream Start indication, replies with BT-A2DP Stream Start Confirm, the stack sends Start Accept to the remote device. Realtek SDK provides a corresponding demo application for developers' reference in development. The BR EDR audio gives a simple example on how to use A2DP. The image describes the file structure of the demo project. For information on handling A2DP API and callback messages, you can refer to the app BT Audio A2DP file. The Audio-Video Remote Control Profile, AVRCP, defines the features and procedures required in order to ensure interoperability between Bluetooth devices with audio-video control functions in the audio-video distribution scenarios. In this profile, the controller translates the detected user action to the AV control signal, and then transmits it to a remote Bluetooth device. The functions available for a conventional infrared remote controller can be realized in this profile. In addition to this, the profile uses Bluetooth-specific extensions to support transfer of metadata related to content to be transferred between Bluetooth devices. The following roles are defined for devices that comply with AVRCP. Controller, a device that initiates a transaction by sending a command frame to a target. Examples for CT are a personal computer, a personal digital assistant, a mobile phone, a remote controller, or an audio or video device, such as an in-car system, headphone, player and recorder, timer, tuner, monitor, etc. Target, a device that receives a command frame and accordingly generates a response frame. Examples for TG are an audio player or recorder, a video player or recorder, a TV, a tuner, an amplifier, or a headphone. This figure shows the relationship between applications, AVRCP, and Bluetooth host. Above the horizon line is developed by the applications. Below the horizon line is developed by Realtek. The application performs AVRCP operations by calling the API and receives the corresponding events and statuses through a callback. The functions provided by AVRCP API are as below. Connecting and disconnecting, including functions to connect or disconnect AVRCP. AVRCP control APIs, including functions to play or pause music, etc. AVRCP browsing APIs, including functions to retrieve information about the available browsable items. Cover art APIs, including functions to retrieve images associated with the media on the TG. More details of AVRCP-related APIs are provided in the SDK. Taking the BT AVRCP Play interface in the Realtek SDK as an example, the interaction flow is shown in the diagram. The application call BT AVRCP Play API. The remote TG device will receive the AVRCP Play command and replied with accept. The application received the BT event AVRCP Play status RSP. Meanwhile, the remote device notified Play status changed, and the application will receive BT event AVRCP Play status changed. Realtek SDK provides a corresponding demo application for developers' reference in development. The EDR audio gives a simple example on how to use AVRCP. The image describes the file structure of the demo project. For information on handling AVRCP API and callback messages, you can refer to the app BT Audio AVRCP file. HFP defines how two devices supporting the hands-free profile shall interact with each other on a point-to-point basis. The most common examples of such devices are in-car hands-free units used together with cellular phones or wearable wireless headsets. An implementation of the hands-free profile typically enables a headset or an embedded hands-free unit to connect wirelessly to a cellular phone for the purposes of acting as the cellular phone's audio input and output mechanism and allowing typical telephony functions to be performed without access to the actual phone. The following roles are defined for HFP. Audio gateway, AG. This is the device that is the gateway of the audio, both for input and output. Typical devices acting as audio gateways are cellular phones. Hands-free unit, HF. This is the device acting as the audio gateway's remote audio input and output mechanism. It also provides some remote control means. The functions provided by HFP API are as below. Connecting and disconnecting, including functions to connect or disconnect HFP. Operating call, including functions to answer or reject call, etc. Notifying call, including functions to notify call event. More details of HFP-related APIs are provided in the SDK. Taking the BT HFP dial last number request interface in the Realtek SDK as an example, the interaction flow is shown in the diagram. The application call BT HFP dial last number request API. The remote device will receive the BLDN command and replied with CIEV event. The application will receive BT event HFP call status. SDK provides a corresponding demo application for developers in development. The EDR audio gives a simple example of how to use HFP. The image describes the file structure of the demo project. For information on handling HFP API and callback messages, you can refer to the app BT Audio HFP file. The Phone Book Access Profile, PBAP, defines the protocols and procedures that shall be used by devices for the retrieval of phonebook objects. It is based on a client-server interaction model where the client device pulls phonebook objects from the server device. The following roles are defined for PBAP. Phonebook server equipment, PSE, this is the device that contains the source phonebook objects. Phonebook client equipment, PCE, this is the device that retrieves phonebook objects from the server equipment. For the hands-free use case, a typical configuration would be a mobile phone as PSE and a hands-free car kit as PCE. The functions provided by profile of BAP API are as below. Connecting and disconnecting, including functions to connect or disconnect PBAP. Getting phonebook, including functions to retrieve the phonebook object from PSE. More details of PBAP-related APIs are provided in the SDK. Taking the BT-BAP phonebook pull interface in the Realtek SDK as an example, the interaction flow is shown in the diagram. The application initiated a BT-BAP phonebook pull, and the peer device received the OBEX GET command, responding with an OBEX continue message. The application received BT event BAP GET phonebook CMPL and checks the data end to determine if the phonebook transfer is complete. If the parameter is false, it uses BT BAP pull continue to continue querying until the data end parameter in BT event BAP GET phonebook CMPL is true. SDK provides a corresponding demo application for developers' reference in development. The EDR PBAP gives a simple example of how to use PBAP as PCE role. The image describes the file structure of the demo project. For information on handling BAP API and callback messages, you can refer to the app BT BAP demo app file. The serial port profile defines the protocols and procedures that shall be used by devices using Bluetooth for RS-232 or similar serial cable emulation. The scenario covered by this profile deals with legacy applications using Bluetooth as a cable replacement through a virtual serial port abstraction, which in itself is operating system dependent. SPP is used to send data through Bluetooth between two devices. The following roles are defined for SPP profile. Device A. This is the device that takes initiative to form a connection to another device. Device B. This is the device that waits for another device to take initiative to connect. For purposes of mapping the serial port profile to the conventional serial port architecture, both device A and device B can be either a data circuit endpoint (DCE) or a data terminal endpoint (DTE). The functions provided by SPP API are as below. Connecting and disconnecting, including functions to connect or disconnect SPP. Sending and receiving data, including functions to send data through SPP between devices. More details of SPP-related APIs are provided in the SDK. Taking the BT SPP data send interface in the Realtek SDK as an example, the interaction flow is shown in the diagram. The application initiated BT SPP data send, and the peer device received BT event SPP data IND. If the peer device also sends SPP data, the application will also receive BT event SPP data IND. SDK provides a corresponding demo application for developers' reference in development. The EDR SPP gives a simple example on how to use SPP. The image describes the file structure of the demo project. For information on handling SPP API and callback messages, you can refer to the app BT SPP demo app file. The IAP profile is always used in authenticated products with an MFI license. It provides a mechanism for reliable and ordered delivery of packetized data belonging to one or more IAP external accessory sessions. The IAP profile is defined by Apple Incorporated. It based on the RFCOM protocol. The figure below shows the protocols and entities used in this profile. The following roles are defined for IAP. Accessory refers to any product that connects to an iPhone, iPad, or iPod device. Device refers to an iPhone, iPad, or iPod. According to the definition above, only the accessory role is supported in Realtek SDK. The IAP profile APIs in SDK can be divided into several parts. IAP initialization APIs. The user must call IAP initialization function before calling other IAP profile APIs. IAP connection control APIs. The user can call these APIs to connect and disconnect IAP profile. IAP control session APIs. The user can call these APIs to send data over IAP control session. IAP external accessory session APIs. The user can call these APIs to send data over IAP external accessory session. More details of IAP-related APIs are provided in the SDK. The Human Interface Device (HID) profile specification defines the protocols, procedures, and features to be used by Bluetooth HID devices and Bluetooth HID hosts. The most common examples of such devices are keyboards and mice used together with computers. The following roles are defined for HID. HID host. This is a device using or requesting the services of a Bluetooth HID device. Examples would be a personal computer or gaming console. HID device. This is a device providing the service of human or other data input and output to and from a Bluetooth HID host. Examples of Bluetooth HID devices are keyboards, mice, and joysticks. The functions provided by HID API are as below. Connecting and disconnecting, including functions to connect or disconnect HID. Sending and receiving data, including functions to send data through HID between devices. More details of HID-related APIs are provided in the SDK. Taking the BT HID host set protocol request interface in the Realtek SDK as an example, the interaction flow is shown in the diagram. The application initiates BT HID host set protocol request, and after the handshake with the peer device, the application receives BT event HID host set protocol RSP. SDK provides a corresponding demo application for developers' reference in development. The EDR HID gives a simple example on how to use HID. The image describes the file structure of the demo project. For information on handling HID API and callback messages, you can refer to the app BT HID demo file. The message access profile defines the features and procedures that shall be used by devices that exchange message objects. It is based on a client-server interaction model where the client initiates the transactions. In general, MAP will be used to combine the messaging capabilities of a messaging server device and the user interface capabilities of a client device for notifying, browsing, reading, deleting, generation and sending of messages. It is especially tailored for the automotive hands-free use case where an onboard terminal device, typically a car kit installed in the car, takes advantage of the messaging capability of a communication device, typically a mobile phone. This profile can, however, also be used for other use cases that require the exchange of messages between two devices. The following roles are defined for MAP. MSE. This is the device that provides the message repository engine, has the ability to provide a client unit with messages that are stored in this device and notifications of changes in its message repository. MCE. This is the device that uses the message repository engine of the MSE for browsing and displaying existing messages and to upload messages created on the MCE to the MSE. The functions provided by MAP APIs are as below. Connecting and disconnecting, including functions to connect or disconnect MAP. Getting message, including functions to retrieve a specific message from the MSE. Pushing message, including functions to push message to the MSE. More details of MAP-related APIs are provided in the SDK. Taking the BT-map MOS message listing get interface in the Realtek SDK as an example, the interaction flow is shown in the diagram. The application initiated BT-map MOS message listing get, and the peer device received the OBEX get command, responding with an OBEX continue message. The application received BT event map get message listing complete and checks the data end to determine whether the message list transfer is complete. If the parameter is false, it uses BT map MOS get continue to continue querying until the data end parameter in BT event map get message listing complete is true. SDK provides a corresponding demo application for developers' reference in development. The EDR map gives a simple example on how to use map as MCE role. The image describes the file structure of the demo project. For information on handling map API and callback messages, you can refer to the app BT map demo file. The OPP defines the requirements for the protocols and procedures that shall be used by the applications providing the object push usage model. This profile makes use of the generic object exchange profile to define the interoperability requirements for the protocols needed by applications. Common devices using these models are notebook PC and mobile phones. The following roles are defined for this profile. Push server. This device provides an object exchange server. In addition to the interoperability requirements defined in this profile, the push server shall comply with the interoperability requirements for the server of the GOEP if not defined in the contrary. Push client. This device pushes and pulls objects to and from the push server. In addition to the interoperability requirements defined in this profile, the push client shall also comply with the interoperability requirements for the client of the GOEP, if not defined to the contrary. The functions provided by OPP API are as below. Connecting and disconnecting, including functions to connect or disconnect OPP. Sending and receiving object, including functions to send objects through OPP between devices. More details of OPP-related APIs are provided in the SDK. The interaction flow for using OPP to transfer data in the Realtek SDK is shown in the diagram. The application initiates the OPP data transfer by first calling BT-op push data header request. The peer device receives BT event OPP data header IND and responds with BT-op send data response. The app receives BT event OPP data RSP and calls BT-op push data request. The peer device receives BT event OPP data IND and responds with BT-op send data respose, continuing until the data transfer is complete. PAN profile describes how two or more Bluetooth-enabled devices can form an ad hoc network and how the same mechanism can be used to access a remote network through a network access point. PAN roles are typically defined as below. Network access points. A NAP is a unit that contains one or more Bluetooth radio devices and acts as a bridge, proxy, or router between a Bluetooth network and some other network technology. Group ad hoc networks. A Bluetooth device that supports the GN service is able to forward Ethernet packets to each of the connected Bluetooth devices, the PAN users, as needed. PAN users. PANU is the Bluetooth device that uses either the NAP or the GN service. PANU supports the client role for both the NAP and GN roles, and direct PANU to PANU communication. The functions provided by PAN APIs are as below. Connecting and disconnecting, including functions to connect or disconnect PAN. Setting filters, including functions to set filters to control which network protocol types shall be filtered and not transmitted. Sending and receiving data, including functions to send Ethernet data. More details of PAN-related APIs are provided in the SDK. SDK provides a corresponding demo application for developers' reference in development. The EDR PAN gives a simple example on how to use PAN. The image describes the file structure of the demo project. For information on handling PAN API and callback messages, you can refer to the app.bt pan demo file. This concludes the introduction to the commonly used profiles in BR/EDR Bluetooth modules. For more detailed information, please refer to the Realtek Online SDK documentation.